Welcome to 7.12's Math Moment. Today students worked with conversions and they were converting different measurements and units of length mainly today between both the customary system that we use here in the US and also the metric system which is used in other parts of the world. So I'm going to go through a couple of different examples, and the first one I'm going to go through using the metric system. So a really good strategy that students have learned is this little saying that says King Henry doesn't usually drink chocolate milk, and those all stand for the different metric units which are then described below. Kilo, hecto, deca, our basic unit, whether you're working with meters, which is length, liters, which is volume, or grams, which is weight. Alright, so whether you're working with any of those units, that U is always your basic unit, whatever one you're working with is just one whole. Then you have deci, centi, and milli. So we're going to look at how we can kind of use these arrows and this to help us as we solve problems where we have to convert from one thing to another within the metric system. So the first example says convert, which we tell students is just a fancy word for change, means the same thing as change. So I want to convert or change 68 meters into kilometers or kilometers. So I always start with whatever I have a number for. We don't like to tell students to start with the first thing because sometimes these might be flip-flopped and you might see it written as blank kilometers equals 68 meters. So we don't want them to say start with the first. We always want to say start with whatever you have a number for. Alright, so I have a number for meters, so that's where I'm going to start. I'm going to place kind of my marker or my finger or whatever they're using on meters, and then I'm going to count how many spaces it takes me to get to what I want. So I start with what I have, and then I count how many spaces and which direction does it take me to get to what I want. So it takes me 1, 2, 3 spaces to get me what I want. And the way that we kind of show this and make this connection is that whenever you have a number, you always want to know where the decimal's at. Well, in a whole number, the decimal is always at the very end. All you have to do is take that decimal and move it that same direction that same amount of times. So if I wanted to move to the left, 1, 2, 3, I fill in any empty spaces with 0, and that becomes my new number and my changed and my converted answer. So 68 meters is the same as 68 thousandths kilometers. Another way to think about it is anytime I'm moving this direction, I'm dividing, so my number should be getting smaller. So this would be the same as 68 divided by 10, 100, 1,000, which again would be 68 thousandths. So if your student wants to actually do the division math and do 68 divided by 1,000, they're going to have to add some decimals and some zeros in order to make that work, but they'll eventually get the problem that they're looking for. Or excuse me, the answer that they're looking for. So the next part of example 1 is very similar. Again, I'm going to go through the steps. I want to first start with wherever or whatever I have a number for. So I'm going to start with centi. That's where I'm going to start on my chart because that's what I have a number for, centimeters. So I'm going to start here and I want to move to M. Now this might be confusing for some students because they see milli is an M, but when you just have one M, that's actually your base unit meters. So that's really the only time that this gets confusing, but millimeters is always written as MM. So that's just something to help your student remember as they're working on their homework. So M would just be meters. So I'm moving from centimeters, 1, 2 spots to the left. I'm getting smaller. Okay, so I want to move 2 spaces this direction to help me move from centimeters to meters. My decimal is at the end because it's a whole number, so I'm going to move 2 spots this way. 1, 2, for a final answer of 56 and 71 hundredths. So again, if your student does not quite understand that portion of it, what they could do is divide, okay, by 2 spots and actually do the math if they'd like as well. Alright, so the next example says find the area of a right triangle. So I've got area and I've got a right triangle that has a base of 20 inches and a height of 2.5 feet. So first of all, I'm finding the area of a triangle, which takes my brain all the way back to my Unit 2 learning when we learned about the area of a triangle. And I know that the area of a triangle is base times height divided by 2. All right, and I have my base is 20, and I have my height, which is 2.5. But students might want to go ahead and just take 20 times 2.5 divided by 2 and think that they're done. But when we're working within these conversions, it's very, very important to notice the unit. And in this case, inches is one of the units and feet is another. And we cannot work with both of those at the same time until they're the same unit. So we've got to take either 20 inches and make it feet, or we've got to take 2.5 feet and make it inches. So we first need to think about, using the U.S. customary system, how many inches are in a foot. So I know, thinking about a ruler, that there are 12 inches in 1 foot. And I also know, thinking about length, that there are 3 feet in a yard. I don't need that information for this problem, but it's just good to have in the back of your head. And then another one would be 36 inches in 1 yard. So I think I'm going to take feet and turn them into inches. Just because I don't want to have to deal with a larger number, I'm going to just take the decimal number and change it to inches. So if I have 2.5 feet and I want to move to inches, students sometimes get confused about whether they should multiply or divide. So we've made, very similar to a chart like this, we've made a chart for the customary system. So you always write your largest unit first, so I would have yards, feet, inches. All right, so this is my customary system. Anytime I'm moving from a larger unit to a smaller unit, I'm going to times. Even though students think larger to smaller, you want smaller, and that would be division, when I have something large and I want to make it a smaller unit, I'm going to have more of those small units. So it makes sense to multiply and get more of that smaller measurement. So then if I'm moving the other direction, I would divide. So this is just an easy way for students to see where they're headed and whether they should multiply or divide. So they would need these 2 reminders to help them know what to do. So I have a number for 2.5 feet, so I'm going to start there. And I want to get to inches, so I'm moving this direction. So I would times in this case. So I'm going to take 2 5/10 and multiply it by how many inches are in 1 foot, which would be 12. And I'm just going to do regular multiplication. 2 times 5 is 10, carry the 1. 2 times 2 is 4, plus 1 is 5. I'm done with my 2, so I add a placeholder 0. 1 times 5 is 5. 1 times 2 is 2. Then I'm going to add to get a final answer of 30, because I want one number behind my decimal. So this is the same as 30 inches instead of 2.5 feet. And now that I have made them the same unit, I'm free to go ahead and solve the problem where I use them both in the problem. So I now can go ahead and do base times height, which is now 20 times 30 divided by 2. Well, I know that 20 times 30, 2 times 3 is 6, plus 2 zeros would be 600 divided by 2. And I know I'm moving around a lot, but I want to have enough space. So I know that 600 divided by 2 is a problem that I need to solve to find my final answer. 2 goes into 6 3 times to get me exactly 6. And then I just have zeros left to bring down, which means I will just have zeros left to put up, for a final answer of 300 inches squared, since we're working with area. So this was a lot of steps. We had to first convert and make the units the same before we could work and solve the problem for area. Okay, there will be problems like this on your students' homework, so really encourage them to be looking and make sure that they don't have any conversion steps to complete before doing the actual problem. If you have any other questions about this lesson, make sure to see your math teacher.